Hello everyone, welcome back to my channel. Today we're gonna continue on our topic of VLANs. Uh, Today we're gonna discuss the topic of inter-VLAN routing. Last time we saw that the packets needed to, well, the VLANs couldn't communicate with each other. So now today we're gonna discuss on how they can communicate with each other. So let's get straight into it. Agenda is the introduction to inter-VLAN routing. I'm gonna also introduce to another topology, router on a stick. I'm gonna give a demonstration of router on a stick network and also give a demo of inter-VLAN routing through a layer 3 switch. So, introduction to inter-VLAN routing. Inter-VLAN routing is the ability to route traffic between VLANs that is normally blocked by the switch. By layer 2 switch, they don't forward IP packets. They only forward traffic based on MAC addresses. Um, because we use VLANs, we are segmenting the network, so some VLANs cannot communicate with each other through a layer 2 switch. That's why we need something known as a router or a multi-layer switch to basically route the traffic between the VLANs. I'm going to give a good rundown on how how this works. Introduction to ROAS, router on a stick. ROAS stands for router on a stick. It's a technique to connect a router with a single physical link to a switch and perform IP routing between VLANs. From a switch's perspective, the link between the router and the switch is trunked to carry all VLANs through. And from the router's perspective, we use another technology called subinterfaces subinterfaces per VLAN. And I'm going to show how to set it up, how to set a router on a stick. There are some drawbacks to a router on a stick. Main drawback being that it's not redundant at all. If one physical link goes down, we could have entire network outage, and it's not particularly recommended to have in an enterprise network. But we're still building on top of what we know. So, yeah, let's start on a demo. So here we have our router on a stick topology. Right now, as you can see, we have one switch connected to three VLANs, VLAN 10, 20, and 30, and we have one router. And in the last video, you saw that we were doing inter-VLAN routing through three physical links. It's not very efficient that way because technically we are occupying three ports on both the switches and the router, which could be used for other purposes. So we are going to use a single link, and I'm going to demonstrate how router on stick works. But first, let's start off from layer 2 and work our way up to layer 3. So here we have our switch. I'm going to assign each port to the VLAN in conf t. FO1 is actually let's clear the VLANs first. VLAN 10, we name this engineering. VLAN 20, name this sales, and VLAN 30, name this HR. Now let's assign each port for its respective VLAN. So int FO1 is VLAN 10. So we do switch port access VLAN 10. No shut. Int FO2 switch port access VLAN 10, VLAN 20. No shut. Int actually it's int FO2. No, int G02. Int FO2 switch port access VLAN 20. No shut. Int FO3 switchboard access VLAN 30, no shut. Now we have set up the 3 links to the VLANs. Now we should also configure the physical link to the router as a trunk link. So int G01 switch port mode trunk, and we should also allow the 3 VLANs to be able to go up to the router. So switch port trunk allowed VLANs 10, 20, and 30. No shut. Now we have done it from our switcher side. Now we need to go and configure it from the router side. So let's go do that. We have a router here. Now I don't want to in conf t int g 000, and first things first, I'm going to do a no shut on the physical link to make the port go up. Now we discussed sub interfaces. I'm going to show how sub interfaces work. So first we do the physical interface. We have a physical interface 0. Then we add dot whatever number you want. I'm going to add dot 10 for VLAN 10 because I want it to match with the VLAN, but there's no restriction that says that you have to do it that way. You could do it whichever way you want. But I'm going to do it dot 10. Once we're in this interface, you can see that the command line changed to sub interface. Before we could assign an IP address to this link, we need to make sure that this is also a trunk link and is carrying a certain VLAN. So encapsulation dot 1q 10. Now this number 10 assigns this port as VLAN 10. This 10 should match with whatever IP address you're giving it. I'm giving this interface, this sub interface, an IP from the VLAN 10 range. So this is also in the VLAN 10 on queue. And then IP address 192.168.1.62, 255.255.255.1 and 2. No shut. Same thing for the other two interfaces. Dot 20 encapsulation dot 1q 20 IP address 192.168.1.126. No shut. Int G000 dot 30 recap solution dot 1q 30 IP address 192.168.1.190. No shut. Now we have set up our network the way we wanted to. We have Inter-VLAN routing working. We could confirm the IP addresses by doing do show IP in brief. Do show IP in brief. And as you can see, we have 3 interfaces with the IP addresses. So let's go ahead and try our scenario here. We're going to move this back over here. And we're going to start a simulation mode. And we're going to ping from PC 0 to PC 2 here. So we ping 192.168.1.129. Sorry, 64, 65. And just before you can see that, I created an ARP packet. Because this is an inter-VLAN routing, and because the destination is in a different subnet entirely, the PC knows that, hey, this device, this destination is in a different network. So it's going to send that packet over to its default gateway. And I have the default gateway set up as the router's subinterface IP. But to send the packet even within its own network, it needs to know the MAC address of the default gateway. So it first ARPs for the default gateway. As you can see, it's an ARP packet, and it's ARPing for the default gateway 1.62. So the ARP will go to its destination, and the default gateway will reply back. And now the PC sends the ICMP ping. It will fail because it does not know, because the default gateway does not know the MAC address of PC2. So it's going to ARP for that first as well. As you can see, it's an ARP packet again. It's going to ARP for PC2. It's going to send it back. And then PC0 will start the packet again. If you take a look at this, it says source 192.168.1.1, destination 1.65. It sees that, hey, this destination is outside my own network, so I'm going to send the packet to my default gateway. That's the MAC address of the default gateway. Send it over, and we have full connectivity between VLAN 10 and VLAN 20. If you go back to our PC, as you can see, reply from all thing. And now if you were to do ping to VLAN 30, we would see that same thing, 192.168.1.129. It will ARP for it first, default gateway will ARP for it, and the first request will fail, and then we have a reply. So there you have it. This is how router on a stick works. Now I'm going to demonstrate how to do InterVLAN routing through a multi-layer switch. So I have here a multi-layer switch. I'm going to quickly just tear down this topology, and then we'll make the topology with the layer 3 switch. So here we have, I connected the switch, multi-layer switch. Now let's configure the multi-layer switch to first, let's configure the VLANs, and then assign the VLANs to the ports. And then we'll do the inter-VLAN routing through the switch, multi-layer switch. I'm just going to make sure that is visible here. All right. So no. I'm going to begin with creating the VLANs first. VLAN 10. We name this engineering. VLAN 20. We name this sales. And VLAN 30. We name this HR. So let's assign the ports to the correct VLANs. Int G101. Switch port access. VLAN 10. No shut. Int G102. Switch port access. VLAN 20. No shut. Int G103. Switch port access. Okay, so now we have the topology fully converged. Now let's do the inter-VLAN routing through VLANs. Now, because multi-layer switch works on both layer 2 and layer 3, it can make so that the VLANs can communicate with each other. So let's see how that works. To do that, we configure the interface VLANs. So int VLAN 10, same thing, except from doing the encapsulation.1q tag, we don't need to do that here. So we could just do IP address 192.168.1.62. No shut. Same thing for int VLAN 20. IP add 192.168.126. No shut. and to VLAN 30. Same thing, IP add 192.168.1.190. No shut. So now we have configured InterVLAN routing, and now if you were to try pings again, it should work. So let's try that. But before we do that, I'm also going to clear the ARP table, ARP-D, just so it doesn't fail ARP-D. Okay, so let's run the simulation again. I'm going to ping 192.168.1.65. And again, it created the ARP packet for its default gateway, like we discussed before. And it sends out the ARP packet. It sees that, hey, this is an ARP packet, replies back, and then finally sends out the MAC or sends out the packet, the ICMP ping. Oh, what happened? What happened there? What is happening? I think we broke it. Oh, 1.65. Oh. Oh, we didn't do one command. We forgot one very important command. And the reason why it was failing, the reason why the pings failed, is because if you were to, because we haven't enabled routing on the switch. To enable a routing, actually, I want to show you something. So if we do a do show IP route, as you can see, we don't have anything here. It says ICMP redirect cache is empty. So right now, this switch, this multi-layer switch, is only working in a layer 2 topologies, in a layer 2 mode. To enable this switch, to enable a multi-layer switch to work in layer 3, we need to add this command IP routing. And now, if you were to do show IP route, we will have all of these 3 routes, as you can see. So we didn't do this before. Yeah, so let's try the pings again. It should work this time. Let's clear the ARP cache and ping 192. Oh, actually, we need to do this again. Ping 192.168.1.65. Here's the ARP request. Now it ARPs again because the switch does not know the MAC address of VLAN 20 or PCE2 VLAN 20. So it ARPs. And now it can finally ping through. And we have a full connectivity between the VLANs. There we go. And if we try pinging 129, it's supposed to should fail the first time because the switch is going to ARP, and then we should have replies. There we go. So that's how we can get multiple VLANs to communicate with each other. Router on a stick, this method is also very good because now we could implement security. We could implement ACLs to prevent certain VLANs from communicating with other VLANs. Yeah, this is the end of Inter-VLAN routing topic. From next video, we're going to start discussing spanning tree and then most likely discuss DSCP. And after that, we'll start working on our actual topology, and then we're going to start discussing more routing based protocols. Thank you for watching. I'll see you guys next time.